In this video, we're going to look at one of the key properties of a straight line, specifically one of the key properties between any 2 points on a straight line, called the midpoint formula. Now, the midpoint formula helps us to calculate halfway between any 2 given points that we have in a system or on a straight line itself. Now, this is very useful, especially when we start to look at bisectors of lines, because we're able to find the point where this line cuts, i.e. bisects, and splits it in half. Now, when you're working with the midpoint formula, one key thing that might help you when you're thinking about it is to think of the midpoint formula as essentially being an average. It's kind of along the same sort of lines as an average, but in this case it's an average of 2 points rather than the average of a quantity or a set of quantities. Now, in order to get the midpoint formula, we have to imagine we've got 2 points. Let's say a point A, located at x1, y1, and a point B, located at x2, y2. We want to find the middle of these 2 points. Well, to find the midpoint of those two, so find the middle of AB, we have to essentially find the average or halfway between each part of the coordinate. So we have to take the x1, x2, we have to take the y1, y2, and find the middle of those. Again, find the average. So to find the average of the two of them, for the x's, we add up the two x's, so we do x1 plus x2, and to average two things, we divide it by 2. And it's the same logic with the y's, except instead of the x parts, it's just the y parts. So we'd use y1 plus y2, and then divide it by 2. We find essentially the average of those 2 points. So, we can work with this in several different ways. First thing being, we can use it to help us find the middle of a line. As I said, this could be very useful, especially when we're looking for a bisector. So imagine I give you 2 points. Imagine I give you the point A, which is -1, 4, and the point B, which I'm going to tell you is located at 7, 8. And I want the middle of these 2 points. So I want the midpoint of AB. Now, to get the midpoint, we use the formula we've just devised up here. So x1 plus x2, y1 plus y2, and divide both of them by 2. So label it. Tell me what your x1, y1, tell me what your x2, y2. And again, as we've found out when we're looking with gradients of lines, it doesn't matter which way round we label the x1, y1 and x2, y2, as long as we're consistent. So x1 and y1 are together, x2 and y2 are together. If this was x1, y2, x2, y1, no, wouldn't work. So we do x1 plus x2, so the way we've labelled it, we've got -1 plus 7. We're going to divide our answer by 2, and we do y1 plus y2, so in this case we've got 4 plus 8, and then we're going to divide that answer by 2 again as well. So -1 plus 7 is 6, divide 6 by 2, we get 3, 4 plus 8 is 12, divide 12 by 2 and we get 6. So the midpoint of any line that contains those 2 points, or the middle of those 2 points themselves, is given by the coordinate 3, 6. Now we can use this in a variety of ways. We can look at equations of perpendicular bisectors, or even just bisectors in general. We can look at equations of straight lines through that part. There's lots of things that it can be useful for. But there are lots of other things that we can use this for in lots of other applications. So imagine I'm going to give you a circle. I'm going to tell you the centre of the circle I'm going to give you with a point C, and I'm going to draw you a diameter. And the diameter goes from a point A to a point B. Now in this diagram, what I'm going to tell you is I'm going to tell you that A has the coordinate 9, -2, and I'm going to tell you that the circle has a centre located at the point C, which is given by 17, 12. Now imagine, after I've told you that the line AB is the diameter, which I mentioned a second ago, I want to know what is the coordinate of B. So what is the coordinate of this point B? Well, first thing we have to do is realise the relationship of these lines. What we know is this is a diameter, C is the centre. We know the diameter of any circle always cuts through the centre exactly halfway. So what we know then is that C is the midpoint of the line AB. So we can use that previous relationship. Let's imagine, for generic terms, we label the point B as just having a coordinate x and y. Well, we can think back to our midpoint formula. We know the middle of a line is x1 plus x2 divided by 2, and y1 plus y2 divided by 2 again as well. If we take these 2 points here, we know that C, that's going to be our midpoint, so that's going to be on this side of the equation, but we know we could take the A and label it as the x1, y1. So that's the part of the formula we know, and the B, the x and the y, that could be our second part for the formula, the x2, y2. Plugging all of this together, what we'll end up getting is that x1 plus x2, so 9 plus x divided by 2, and the y part gives you negative 2 plus y divided by 2. It's going to equal the coordinate of our centre, which in this case is 17, 12. Now what this allows me to do is create two separate little equations, one for finding this and one for finding this, that I can solve fairly easily. What it allows me to do is set up an equation saying 9 plus x divided by 2 is 17, and another one saying negative 2 plus y divided by 2 is equal to 12. And I can solve both of these equations. So this first one here, I get that 9 plus x equals 34. So 9 plus something is 34, x equals 25. And in this one, I would end up doing the exact same start. Get negative 2 plus y equals 24. Solve it around, I get y equals 26. So what this then therefore allows me to do is say that the point B is located at the point 25, 26. I can use the midpoint formula to reverse engineer essentially my scenario to get the other side of the line if I know the middle of it. The midpoint formula has many uses, it really does, and it's a key skill we have to be able to work with, and this right here is the formula that makes it all happen. x1 plus x2 over 2, y1 plus y2 over 2 gives me the middle of my line.